Hi and welcome to this new video in which I will conclude this first introduction to semantic kernel in C#, and this time we will combine all what we saw in the previous three videos to obtain the final result that is the most interesting one. First of all, as I told you, we will combine results and techniques from the previous video. We will use a YAML file to create a simple plugin with handlebars syntax to define a chat prompt to interact with a large language model in a chat model. Then we will use the plugin import configuration from the kernel builder class to allow kernel builder to automatically import plugin. But this time we are going to use a small change in the configuration, and it's the small change that gives semantic kernel its power, because we will allow semantic kernel to directly and automatically use the loaded plugin to accomplish a task to satisfy the user question. So we will not invoke all the plugin manually. We don't need to know the parameter. We will simply interact with a natural language, as we saw in the Python example. And he is the guest of this video. His name is Lucifer, and he is really interested in learning semantic kernel. So it is near me to grasp all the little details about using semantic kernel. Now, all the example is absolutely equal to the previous example. The only real difference is in the line 184, where in the OpenAI prompt execution setting, I'm simply specifying AutoInvokeKernel function, and that is the key. So as you can see, in the previous lines, I've simply configured the kernel builder to import the plugin, and then in the following line, 187 and so on, I'm simply loading the YAML prompt from the chat, from the prompts directory, and everything is ready to invoke my functions. As a reminder, the YAML file with the chat YAML file contains only a prompt with handlebars syntax, and I'm simply going to load all the content and create a kernel function directly from a prompt. So instead of using a kernel function from a plugin, I'm creating from a YAML file, from a prompt. And then I creating the chat history message, but this time I'm not creating a kernel argument function. I'm simply creating a chat model, and I'm simply telling to the system, to my assistant, I want to extract audio from video file, and I give my path of the file. Okay, now I've executed my new code, and I've called the InvokeAsync function, and you can verify that it called extracting audio file. It has a previous call to a large language model. What happens is that semantic kernel now has the superpower of using the plugin to satisfy the user request. So it asked to the large language model, hey, these are my plugins, and this is the question of the user I want to extract audio from. In the LLM answer, you can use the extract audio plugin, and so on. So the extract audio plugin was called. Then after the audio plugin was called, it still asked to the large language model to do something. And you can verify this if you simply look at what is in the result object. Okay, so what is the final result of the InvokeAsync function? As you can see, the result is much more descriptive. The result is the audio has been successfully extracted from the video file and saved if you need further assistance. So it is basically the interaction you have with an assistant. So you ask something to the assistant, the semantic kernel orchestrates everything, asks to the large language model which are the function, the plugin that can satisfy the result of the user. It directly calls my functions, and after everything, it will create a final answer for me in which it told me what it did and what I got in result, and it's what I want. I asked him to just to extract the audio from an MP4 file, and it decided to call the extract audio plugin, and everything is okay. As a final example, I try to ask something more complex. So my question is, I want to extract summarized timeline from the video file. So what I want is for Semantic Kernel to do what I did in the previous example, to call all of my 3 plugins. The first one used to extract audio, the second one used to extract a full timeline, and the third one used to get a summarize the timeline so I can include in the description of my YouTube video. And now I'm using a single question to my semantic kernel to understand if it is capable of orchestrating everything for me. As you can see, the prompt is proceeding because actually it extracted the audio file. And then as you see, there's a progress bar that is starting. It is going to actually use the Python invoker to invoke my OpenAI wrapper. And so it is converting the audio. So it is proceeding. After a little bit, it gives me the result. And I'm going to write the result to see what actually I got as an answer. And as you can see, here is a summarized timeline and blah, 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 where it actually gives me a result. But I need to give you one warning. As you can see, this is different from what we got with the previous example. And that is because after the semantic kernel invoked my summarization plugin and got the summarized plugin, it will still go to another round of requests to the large language model to create the final answer. So actually the final answer is not actually what I'd like to do, but this allows me to explain how with a simple option you can give semantic kernel the ability to call your plugin so it can fulfill a complex user request, just orchestrating your plugin call after call. So what semantic kernel does is asking to the large language model, what can I do next with this situation, with this question and this plugin? And each time it invokes a plugin, it gets a new result, it gets a new piece of the puzzle, and it's continuing to go to try to invoke the large language model asking, what should I do next, until it can fulfill the request of the user. And this is a real power interaction with a very few lines of code. Just to remember, I simply create some function in C# or simple prompt, and I simply use arguments to let semantic kernel import as a plugin. And then with a few lines of code, I configure the kernel to import the plugin. I give the kernel the power to invoke my function, and I simply ask a question and I got an answer back. And this basically concludes our introduction to semantic kernel in C#, where we saw how easy it's to import a plugin, create a plugin, and actually tell semantic kernel to invoke a prompt and automatically use the plugin into an interaction way in which each time semantic kernel asks to the large language model, what can I do next? And the large language model explain which is the next function it can call to satisfy the user request. And we saw how this makes possible to simply let the user ask, I want a complete transcript of my MP4 file, and it understands that first you need to extract the audio file, then you need to create the transcript, and then you need to call the summarization plugin that compresses the transcript into a summarized timeline. And I hope you enjoyed the video, and see you in the next video of this series about semantic kernel.